RoboPapa.
Hey YouTubers, we're Papa, and today we're going to do the second episode of Coding with C Sharp, and we specifically will talk about the C Sharp primitives, and hopefully we'll also be able to get into the flow within C Sharp, like if statements and switch case statements. So we'll do everything on the computer, and we'll base it on the first video, the first lesson that we did last time, and you can click basically right over here. That way you can see the first video if you missed it. So we have many things to cover, so let's get started.
Alright, so here we are in the solution from last time with the Hello World. If you haven't catched that up, please go to the first lesson where I'm showing how to basically output Hello World and the different kinds of the console method. But before we start with the primitives, we'd like to touch on how the value is actually being stored and what are the primitives within the C Sharp. So the most common denominator of the computer language, which is binary language, is a bit, and a bit is just a true, false, or 1 and 0. It's just kind of like an on-off switch. After the bit, if you combine 8 of those, you will get the byte. So a byte is equal to 8 bits, and it's just a sequence of zeros and ones. From the byte, you have the kilobyte, which is 1024 bytes. The megabyte is 1024 kilobytes. Gigabyte is 1024 megabyte, etc. So it's always a multiplication of 1024, which is 2 to the power of 10. So basically the computer is all it does, it's just saving it like this, and we'll see kind of like how it's affecting later on in the episode. As far as the primitives within the C Sharp, we can divide them to 3 categories. The numbers, a Boolean, and a text. Within the numbers, you'll have a couple of options. Integer, which are basically whole numbers, negative and positives. So for example, -10, 0, a million, and there's a min and max depending on how many bytes the integer is actually holding. And I'll show you a couple of examples. Then you can have a floating point, which can represent as a float or a double. And once again, you can do 2.2, 3.145, or very small numbers. And the difference between the double and the float is once again the amount of numbers that it actually can store, or the floating point that it actually can represent. The next one is actually the long, which is the same thing as the integer. Just once again, it's more memory. It takes more memory, and therefore it can have larger values. And then a decimal, which is a very long number, and you can see the maximum value over here. Within those primitives, there's what you call unsigned int, or unsigned, sorry, like unsigned int, unsigned long, unsigned decimal, etc. And basically all it does, it's using the most significant bit, which is the last bit, right? The last bit of the values, to use it as a number. So with the machine, the most significant bit is indicating if it's a negative number or not. So if it's on, which is 1, it represents a negative number. If it's 0, it represents a positive number. But for unsigned int, that bit, that last bit, is actually using for representing a number, like not a negative number. And that's why the range is actually increasing. So for unsigned values, it will go from 0 to basically the maximum of the unsigned itself. Boolean is basically self-explanatory. It's a true or false, or 0 and 1. It's just one single bit, and it can be either on or off. Text, you can divide it to 2. One of them is characters, which is represented by 8 bits, which is 1 byte, and what it's called of an ASCII value. And I'll show you over here like the ASCII table. I'll post a link to one of those tables, that way you can actually have a reference for it. but you can see over here the decimal value of it, and then on the red is basically the character that it's representing. So for example, the character A, uppercase A, it's in decimal is 65, and that's how the computer knows. Your keyboard is actually working with this kind of table. If you are having a different language than English, you can see that's stopping over here on 127, and 127 is actually not 8 bits. It's actually needing less than 8 bits. It needs 7. So probably asking, where's the extra one? Well, the extra bit is going for the 128 to 255, and those are the extended ASCII table. And those characters are usually for foreign languages and stuff like that. So an example of character will be like the tilde or 0. Even a comma is one of the characters, the number 9. A to Z characters, capital or lowercase a to Z. Those will be part of the characters. And then a string is basically just a collection of those characters, right? I mean, we saw in the first episode that we output over here in the hello world. Well, that is a string that's representing by multiple characters. So the H, the white space, the W, those are basically the ASCIIs and characters collection. So, for example, if we'll take the ASCII with A, we saw that the decimal value over here for A is 65. So if we'll put that 65 as a binary, we'll get this value. If you're working with Windows, you'll be able to use the calculator over here. You probably will have it on the standard, but you can click on View, Programmer, and now we will have actually the options to convert certain things. So if we put on decimal, we'll put the value 65. It will say change it to binary, which you don't have to. You can actually see it already here. But if I change it to binary, you can see that now it's converting it to binary. So 65 in binary means this value. And I'll touch how you can actually calculate that 65 is actually this in later episodes. So that character A, which is decimal value 65, in a binary code will be this. And I'll show you later how actually the machine really doesn't know if you meant the character A or did you really meant the number 65. And it depends on you as a programmer to actually use these values correctly. So let's take an example of all the primitives and what we can do with them. So I have a small snippet of code over here, that way you don't need to watch me typing, that basically taking the primitives, integer, floats, doubles over here, long, and decimal, and it will actually output our max and min value for each one of them. And actually, let's take it like one step further and we'll show the size of each one of those. So there's a function that's called sizeof, and we can just give it the int, and we don't need those duplicated rows for each one of those. So size of float and that will actually output us the how many bytes the computer or the compiler is actually using for each one of those. So let's take a look at this. First we'll look at the max and min value. So you can see, because we're using int, the max and min are a little bit like the normal one. Then the minimum is negative 2.1 million, the max is 2.1 million. If we used unsigned int, which means it go from 0, it will use the last bit, so the most significant bit, and to use that for another number, and therefore your max value will be increasing and it will be double, because now you can use that number to represent you can use this. Sorry, you can use this bit to represent numbers. So you can see over here the values, and this is the value for the decimal itself. But most importantly, if we look over here, that the size of int, is actually 4 bytes, and 4 bytes is representing this. So if we'll go back to our calculator, and we'll let's put in a binary, and we need 4 bytes. So 4 bytes is 32 bits. So if we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can see on the computer over here on the calculator, we can stop over here. That will give us 32, and we convert it to decimal. Oops, I had one more. I had one extra one. Let me do that again real quick. Sorry about that. Just had an extra one. Because don't forget that we're starting from index 0. So you don't need to go to 32, you need to go to 31. So you can see if I used the most significant bit, which is over here on the bit 31, suddenly my number over here is doubled, because I can use that one. So 4 bytes, that's basically 32 bits, starting from index 0 to 31. Float has the same size, and it's just can represent negative floating point numbers. The long, like I said, it's just like integer, but it's a larger number, and the reason is because it's using 8 bytes, so it's double the amount. And double is using double of the float, so once again 8 bytes. And then decimal is using 16 bytes, so that's why you can represent a very large number. So that's basically like just an overview on the sizes and the min and max values. So let's take this into an action, and if you remember, I told you it depends on the programmer what they're doing with the value, and it can represent 2 different things. So let's use like a char, which is 1 character, and we'll call it ch. And if we'll give it the character A, and we'll output it, we'll actually get the character A over here. But if we'll convert that character to an integer, which means that we're telling it, give me this character, which is a char, and convert it to an integer, it will give you the value of that A, which is 65. We can do the same thing, for example, with let's say lowercase z. If you remember from the table, lowercase z is 122. So 122, if we'll compile that, there you go. Alright, so if we continue on, and let's take a look on the Boolean values, for example. So like I said, Boolean values are really just true or false values. So if we use this as char, and let's create another Boolean, and we call it is z, and we'll ask if the char itself is equal to z, and we'll output that az. And then we can do this, can assign again the letter, let's say y, capital Y, and we can ask the same question. Console.writeLine, and then ez. So before we actually compile that, I want to touch on something over here. So the way you actually declaring variables, I mean, that's very important, and which I think that I skipped in my previous example. You're giving it the type, which right now it's char, type of character or type of Boolean. You're giving it a name, which capitalization is very important, and there are certain characters that you cannot start the name of your variable with. For example, dot or bang, exclamation mark, the tilde, question mark. I guess you can. I didn't think you can. You cannot start it with a number, but you can actually have a number after the first character. Underscore is okay. And then obviously all the alphabet. So like you can start it with a capital A or capital B, etc., and then lower cases. There are certain code standards, which is like camel case or Pascal case, but those are something you can read online. Most people using these days the camel case standards. So once again, the type of the variable, the name, and then if you want to assign it to a certain value, you're giving it that constant value. It's called a constant because you cannot actually change what z value is. It's always going to be z. And because it's a character, I put it on a single quote. If, for example, I had something that it's a string, right, I will give it double quotes. So that A, B, C as an example. That is representing a string, just like we have over here, which is a string array, and we'll touch about arrays later on in future episodes. Right, so that's how you're actually declaring the variable. So let's see what's going on over here. We outputting it. We show how we can actually have the same variable. Outputting it as an integer will give you actually the value of z, which was 122. Then we're creating a Boolean value over here, which then we checking to see if a certain condition is actually true or false. For example, is ch is equal to z. Should probably change this one to z as well. And then because it's case sensitive, it's important if it's lowercase z or uppercase z. So over here we're checking it to see if it's lowercase z, which should tell us that it's actually true, and that's what we'll output. Then we reassign the ch to uppercase y, and we trying to do the same check over here. We're assigning the condition of ch equal to z. This is a condition. Equal is a condition, while one equal is actually assignment. So double equals condition, single equal is assignment. So that condition is going to be reassigned to a z over here, which at this point it will be false because capital Y is not equal to lowercase z, and we'll output over here. So let's see how what's the output over here. Yep. So as you can see, we started with the z over here. We're outputting it, then we're outputting the value, the integer ASCII value for it, which is 122. Checking the condition if the z, lowercase z, is actually equal to lowercase z, and we got the true. We're reassigning it to y and checking again if it's equal to lowercase z, which we got the false. So that's in a way kind of like how you can do some parameters with the primitives within C#. The same methodology you can do with, like I said, strings over here, double, float, decimal, longs, and even the unsigned. Actually, let's take an example of the unsigned because that will be an interesting. Let's say that we having an unsigned int, and we call it I don't know, h, and we know h can be only from 0 to a positive number, which hopefully everyone will live long life. So let's say that that person lives on to 120, and we'll try to output it. And we'll put h. So we'll say your age is, and that I'll explain in a minute what this actually means. Then we'll try to, if we run that, so we can see your age is 120. So now you're saying probably, wait, how did he know that to put 120 over here, right? Well, that's a nice thing about the right line. It's doing by itself a string format, and basically we're telling it output this string, but replace this curly braces 0 with whatever comes as the first, because this is the 0, it's the first element that comes after. I can actually put over here a second one, which I can actually let's say put the value 10, and now you can see 120 and 10. So the second one, which is index 1, because we're starting with index 0, becomes the second parameter, which is to 10. We'll replace it with 1. So the right line knows to take this string format and replace it with these parameters. So it's pretty nice method if you want to format your output and stuff like that. But let's say that right now we're trying to actually assign a negative number to age, right? So you can already see that I have this curly red line because I have ReSharper, which is a tool. But if I'll try to build it, now I can get over here constant value -1 cannot be converted to uint when uint is unsigned int. And if you double click on that arrow, it actually will take you to that. So because this one is unsigned int, the compiler knows, hey, you cannot actually assign -1 to that because, hey, I need to use this last bit to have bigger values. So this will give you a compiler error. So the minute that we actually remove it and we'll try to build, you can see that it succeeded. Alright, so that is basically how you do primitives and their assignments. So our next section is about flow control. And just like in English, you have the if statement and you want to use that. So the way it's working, you just start writing if, and then you give in over here a condition, right? A true or false condition, a Boolean condition. Well, it will not let me type that like that. So let me put a comment. So condition, and that's, by the way, comments with C#. If you want to have multi-line, you do /* and you're finishing it with */, and then everything else that comes within those, as you can see, it's green. It's actually a comment. So the compiler will actually ignore it. So if I build it now, it will be fine, right? But if I put it that gibberish over here and I'll try to build, it will actually complain. Even if I try to put the semicolon like it's requested, doesn't know what it is. So that's multi-line comment. Single line comment is just whack whack, like //. And you don't have to put the white space. It's just for me to show you guys that now this one is a comment also, and if I'll build, it's actually successful. Alright, so that's kind of like a sidetrack about comments. Conditions. So the if statement, in the middle of it, basically it's qualifying on a certain condition that has to give you a true or false value, right? That way we'll know if it needs to execute this or not. And then you put the curly braces, and you put your code within this curly braces that's supposed to execute the if statement. And usually after that will come else, and you can put another if, right? And like that, and then you can end it with just an else, like that. So basically you have the if keyword, you're giving it a condition of true or false, then you're running the code within it if it's true. If it's false, it will go to the next statement. If it's an if statement, it will try to do the condition within it. If that condition is becoming true, it will execute this second code, not the first one, not the last one, but the second code. If the condition over here is false, if there's an else, it will execute it. If there's an else if, it will execute the next condition, and going on until it actually can execute something, or it doesn't have to. If it's like this, it will just, if this condition is false, it will do nothing. So let's take a look on something. There is a class named random, which is basically a random generator class or object. So I'll generate something over here, and let's take a value, let's say score. We'll try to give like a B C D F school score over here in the US, and we'll generate the next number, and we'll give it a minimum of 0, maximum of 100. So 90 to 100 will be A, 80 to 90 will be B, 70 to 80 will be C, 60 to 70 will be D, and then everything below 60 will be F. So let's start actually asking that, right? We can ask if score is greater or equal to 90. Then we can actually output, let's actually, instead of outputting, we'll call it letter score. Letter score. For some reason my shift is not working, so forgive me that it's not capital S. And for now it will just be like that. If the score is greater or equal to 90, the letter score needs to be assigned to A, because the student got it above or equal to 90. Otherwise, we'll check to see if the score is greater or equal to 80. And the reason that we can do that is if the score was 90 or above, we'll know we already got here, which means that if we got to this condition, we know it's not greater or equal to 90. So we can actually assign this to be a B if it's greater or equal to 80. And the same methodology is for the next one, which is greater or equal to 70. That will be equal to C. If score is greater or equal to 60, then the letter score will be equal to D. Otherwise, at this point, we don't need to check to see if it's greater or equal to 50 and then 40, 30, 20, because all of those is going to give you the same score, which is basically a F score. So let's go real quick on this. We generating a random number between 0 to 100. We're assigning it to score. Then we declaring a character that we will hold the score for, and we call it letter score. And we checking to see if this score, which is an integer, is greater or equal to 90. We know that the student will get an A. So even if it was 95, it will still be here. It will qualify on this. This condition will be true because it's greater or equal to 90. If it's not greater or equal to 90, we'll check to see if it's greater or equal to 80. If it's greater or equal to 80, we know it will be between 80 and 90 because it failed on the first condition. So we know the student can get a B. Same thing will be with 70. If it got to here and it's true, we know it cannot be bigger than 80 because it failed the 90 and it failed the 80 condition. Those two came as false, and therefore we can assign it as a C. And the same thing is for 60, and by default the student will get an F if it was not qualifying for the score. And then we'll just output the word yes, and then we'll break from it. If I didn't put a break over here, it will complain because I have to continue with only one chaining like that. So the minute I have some code, it has to break it. And I continue like this until 60, which at that point we can actually make it as a default, and we can output over here oh no, and we will break. So if we run this code right now, as long as our score is 100 or between 99 to 95, we'll output wow or yes. Otherwise everything else will be oh no. So if we'll look at this, now we have oh no, just to be complete, and that way we can see what is the score that we actually evaluated with oh no. We'll do like this. Once again, we'll output the score itself. So now it's yes, which means that it was either 99 to 95. If we run it again, we're getting an F over here. So oh no, we got a 3, which is a really bad grade. So that's basically it, guys. That's the flow control. You have the if statements, you have the switch. We touched about primitives and their values and the unsigned primitives. especially for the for numbers. That way you can increase it. We touched a little bit about the binary code and the ASCII table over here in the binary code, and how actually the same binary value, if you're using a character, it will output you this A over here because of this, or if you use an integer, it will output you the 65, which is the decimal value of A over here. So if you have any comments or questions, I know that I covered a lot of things and maybe I moved a little bit too fast. Please let me know. Leave me a comment below, and I'll definitely will answer you as soon as possible. And don't forget to subscribe, because more videos like that coming, and we'll get into more detail of like methods. Like, for example, what is this main? You'll probably ask yourself, what is this main, and why I'm not explaining to you what it is. I'll touch with the next episodes what methods are and how you can pass parameters like this string array into it, and what are they good for. And we'll have a little bit more advanced, and slowly we'll get into more interesting things and stuff within the C# world. It's very nice language and libraries framework to work with. Obviously there's the using statements and the namespace and what those are. So yeah, definitely subscribe, that way you can get notifications about it. So that's it for now, guys. Until next time, thanks.